Okay, let's proceed to this problem. To express this in single log, we apply the quotient rule. So this is now log base 2 of x plus 1 over x minus 4, which is less than or equal to 3. Now we can remove the log by raising it up base 2. Okay, so this will cancel out, and this becomes x plus 1 over x minus 4 is less than or equal to 2 to the third is 8. And then we can move this to the left hand side. Okay, so this is now x plus 1 over x minus 4 minus 8. Okay, this is less than or equal to 0. Now remember, we cannot cross multiply this because we have a variable here. We don't know our x is either positive or negative, so it can change the inequality. So we need to be consistent with our inequality, so we only subtract both sides by 8 this time. Because subtraction or addition, both sides cannot affect the inequality. Okay, now let's apply the LCD. This is x plus 1. Okay, the LCD is x minus 4. So let's multiply this to 8. So that is 8x, negative 8 times negative 4. That's positive 32. All less than equal to 0. Okay, now let's simplify this. This is negative 7x and 32 plus 1, that's 33 over x minus 4. It's less than or equal to 0. Now here we can get the critical points. The critical points are, alright, let's begin from the numerator. That's negative 7x plus 33 equated to 0. So we have negative 7x equals negative 33, and we divide negative 7 both sides. Okay, this will cancel out, so x equals 33 over 7. Okay, next for the denominator we have x minus 4 equating it to 0, so x equals 4. Now let's do the test points method. 33 divided by 7, that is 4, approximately 4. That's 28, so you have remainder 5. 53 divided by 7, so we got 0.7, so approximately 4.7. So we have, let's plot our points here, 4 and 4.7. Okay, so we take a test point here, 0, easier. Between 4 and 4.7, let's take 4.5. And here we can take 5. Alright, now let's go back to our inequality here. Okay, this is the inequality that we're going to test with these points. So when x is 0, so this is 0 plus 33, so the numerator becomes positive, and the denominator, if this is 0, that's negative. Okay, and positive divided by negative is negative, so the inequality here is negative, so this is true. Now let's do to 4.5. So if we have 4.5 here, so negative 7, let's do it somewhere here. Okay, negative 7 times 4.5 plus 33 over 4.5 minus 4. So our numerator is clearly positive. it remains to show the numerator. So 7 times 5, that is 35, carry 3. 7 times 4, that is 28, plus 3 is 31. 0.5 plus this negative, so plus 33. So positive is greater, so this is positive. So positive divided by positive is positive, and this is false because our inequality here is negative. False here. And let's try 5. So negative 7 times 5, that's negative 35 plus 33 gives us negative. And then the denominator, 5 minus 4 is 1, so that's positive. Negative divided by positive is negative. So this is true. And our partial solution here, let's say solution 1, that is from negative infinity to 4. Now take note, our 4 is in the denominator, so let's open union with 4.7 or 33 over 7 to positive infinity. By the way, this is closed because that's from the numerator, and equality is less than or equal. So equality, the endpoints is included here. And this goes to positive infinity. Okay, next let's continue here. We still have to deal with the domain. Okay, the restriction. Okay, so for this term here, x plus 1 must be positive. That implies x is greater than negative 1. And for this second term here, x minus 4 must be positive, so x is greater than 4. Now let's graph this. Negative 1 and 4. We'll take the intersection of these two intervals. This one, x is greater than negative 1, so x is on the right side. It goes there. And this one is greater than 4, so x goes to the right side again. So the intersection, okay, because this is an statement, so the intersection will be, or they're common, this point. Okay, so it starts from 4 to positive infinity. Well, let's write this as our partial solution SS2. So this is from 4 to positive infinity. Now we're going to intersect our two intervals, SS1 intersection with SS2, to get our final solution set. Our solution set 1 is the interval negative infinity to 4. Okay, union with 33 over 7 to positive infinity. And then we're going to intersect this set by interval 4 to positive infinity. Now let's continue here. I will draw the graph using blue color. Okay, let's write down the endpoints. So all the endpoints here, we got 4. Okay, and then the other one is 33 over 7. That's approximately 4.7. Let's take that 4.7. And then let's plot this one. Here, that's from negative infinity, open, to 4. And then union with 33, that's close to positive infinity. And then this one, intersection of this one is from 4 to positive infinity. Now let's take the common points, the intersection of these intervals, their common would be here. Okay, this is the common. So starting from here, including the endpoint to positive infinity. Therefore, the solution set is equal to the interval 4.7 or 33/7 to positive infinity. Okay, to check our answer using a graph, we can rewrite this as log base 2 of x plus 1 minus log base 2 x minus 4, and then we transfer this to the left side, so we have minus 3, and it's gonna be less than equal to 0. So if we write this into, if we let this equal to y, so that we can graph this one and take the negative value of our y, okay, to check it out. So we're using this calculator. Okay, this is now our equation, and let's check the graph. So this is now the graph, the curve of our y. Okay, now based from the inequality, our y should be positive. So if you look at here, our y starts getting negative at the value of around 4.7. okay, something here goes down, becomes negative and negative. Hence our solution here, which is 33/7 to positive infinity, is correct using the graphical method. Alright, in a case where our base is less than 1, so it's gonna be different. So let's raise this with a base 1/2 so that we can remove our log function. Both raise it base 1/2 both sides, so our log here will be eliminated, and we have now x plus 1, which is now this time our right hand side will be 1 to the 2 is 1, and 2 to the 2 is 4. We simply distribute the exponent 2. Okay, so we have 4. This side, our left side, is bigger than the right side. So if our base is less than 1, okay, let's write our 1/2 as 0.5. Okay, the other side 0.5. If you raise this, if the denominator of this is bigger, say for example, let's try 4, and this one is smaller, let's try 2, then the value of this one, the value of this is 0.5 times 0.5 is 0.25, and this one you multiply 0.5 4 times, you get 0.0625. So hence this one is greater. The one with a smaller exponent will be greater than the one with a bigger exponent if our base is less than 1. So in a case where our base is greater than 1, this one our base is less than 1. In a case where our base is greater than 1, so say for example 2, this one 2 here, if we raise this to the power of 2, and this one is 4, so the exponent here is bigger, this one is smaller, so the result here will be 16, and this one will be 4. So the one with a bigger exponent will yield the bigger value. So that's the difference if your base is less than 1 and base is greater than 1. So let's go back to our problem. Since our base is less than 1, so the inequality will be reversed because this one has the bigger exponent here. This one is smaller, so the smaller exponent will have the bigger value. So the inequality will be reversed. Now let's solve for our x. Let's move our positive y to the right side. We have 1/4 minus 1, so x is less than, okay, that's 4 or 1 minus 4, that's -3 over 4. So if you plot the interval, just see, there's -3/4 here, so our x is less than -3/4, so that's on the left side, and it's open over there. And for our domain, okay, our domain is x plus 1 should be greater than 0, so x should be greater than -1. Now -1 is smaller than -3/4, so it's somewhere here, -1. So this interval is -1. X is bigger, so it's on the right side. X is on the right side of -1, so it's going there. Now let's write down the interval here. The interval here is from -infinity to -3/4. Okay, interval here from -1 to +infinity. Let's combine these two intervals together. We have -1 here and -3/4. So this one, -3/4, going to the left, and then from -1 going to the right. So their intersection, or their common points here, starts from -1 to -3/4. So therefore the solution set is from interval -1 to -3/4. Okay, you can also write this in set notation, the set of the x element of real number, such that our x is greater than -1 and less than -3/4. Let's verify our solution set. So let's express it again into equation. We have log of base 1 over 2 x plus 1. Then let's move this to the left side, that's -2. And let's express this as an equation, y. Alright, now we're looking for the value y that is positive. Since we're moving the 2 to the left side, so that will be -2 greater than 0. Now using the graphing calculator, okay, let's check it out. So in the graphing calculator, I'm using 0.5 instead of 1/2. So this is log 0.5 of x plus 1 minus 2. And let's look at the curve. Our solution says that we start from -1 up to -3/4, and they're open intervals. Now if we look at this graph, okay, so we're looking at the positive y values. The positive starts from its asymptote -1, okay, and then it goes down to, okay, this is approximately -0.75. Let's check it out. Okay, that's -0.75. That's the x and the y is 0.